Dear friends, I myself, Dr. Bharat Parab, discussing the topic Introduction to Euclid's Geometry. Let us consider some examples. First one, in Harappa and Mohenjo-daro, the city existed some 5,000 years back in Indus Valley. We see houses and roads follow geometrical rules. Even the bricks used were in the ratio length into breadth is to thickness in 4 is to 2 is to 1. Okay, so this was the ratio of the bricks used. This shows that they were using geometry in their life. See, it was 5,000 years back. Okay, so they were aware of these geometrical rules. Okay, second example, very interesting example. All the 12 Jyotirlings, you know, Jyotirlings, there are 12. So all the 12 Jyotirlings are placed in such a manner that they form conch, a conch, okay, formed by certain equation. There is very advanced geometry in this. You may come across this geometry in higher standards. Okay, these are only examples that geometry is being used for many years, many thousands of years back. They were knowing geometrical rules. Okay, so we will see how it forms conch in the next slide. Okay, so now go through this interesting map. Okay, 12 Jyotirlings. This is map of India, and see, it starts from Krishneshwar, goes like this. Okay, it's not that it's going arbitrary like this. There is a perfect equation related to this. You may come across this or may study it for higher standards, but for in the present case, this is out of the scope of your syllabus at present. Okay, but there is very much advanced geometry related to this. Okay, so remember that they were knowing geometrical rules and geometry even 1,000 years back. Okay, third example, Sri Yantra. This is Sri Yantra. Look at it. This is very complicated. Okay, an interesting fact is this was invented some 1,000 years back. Okay, so Sri Yantra is a complex geometric diagram that consists of 9 interlocking triangles. Okay, it is a sacred symbol in Hinduism that is used for meditation and worship. Okay, we will have some information about the Sri Yantra in the next slide. This information is beyond the scope of your study, but you should know that geometrical rules were used from ancient time, or our ancestors were knowing geometry very well. Okay, so this is the information about Sri Yantra. Just reading this, the Sri Yantra's 9 consistent triangles vary in size and shape and intersect to form 43 smaller triangles organized in 5 concentric levels. Okay, together they represent the totality of cosmos and express Advaita or non-duality. In the middle, the power point or Bindu represents the cosmic center. Okay, though accurate geometrical methods were used for the constructions of this, the principles behind them were not discussed. Okay, this knowledge was transferred from one generation to another orally. Okay, so these are 3 examples where very advanced geometry was used. So we will go to the comment. These are some examples where very advanced geometry has been used. These examples shows that the geometry was used all over the world, but in unsymmetric manner. They, there were many civilizations. So many civilizations like Babylon, Egypt, India and Rome were aware of the geometrical rules, equations, and calculations, but in their frame of reference. So what India was doing, Indian people were doing, these people were they were not knowing, or they were doing, others were not doing like that. Okay. So but the Greek civilization developed geometry in systematic manner and were interested in reasoning and establishing the truth of the statements by deductive reasoning. Very important aspect. Okay. So we shall discuss deductive reasoning in details in this topic, but in another video of appendix 1. Okay. So you can contact me for this, and I shall give you link where deductive reasoning has been explained properly in details. Okay. So now let us have a look on the names of some great mathematicians of ancient time. The first one, a Greek mathematician, Thales, is credited with giving the first known proof of a circle is bisected or cut into two halves by its diameter. Okay, this was the proof given by him that diameter cuts the circle into equal parts. Okay, and Thales 640 BCE to 546 BCE. Okay, and another is Pythagoras. The Pythagoras too discovered many proofs, and you know one of the proof by his name. Okay, so we move ahead. Now look at it. An Egyptian teacher, Euclid, developed a geometry in systematic manner. He called a treatise as Elements, collected into 13 chapters and called a book. Okay, we are discussing Euclid geometry and try to link to present geometry in this topic. Okay, so this is that great mathematician. He was a teacher. Okay, so Euclid 325 BCE to 265 BCE. Okay, so now we are starting Euclid's geometry. For that, this is a pre-preparation to study that. Okay, we are starting with Euclid's definitions, axioms, and postulates. Okay, now read this. Euclid developed a solid object. Remember this solid object that has shape, size, position, and can be moved from one place to another. Clear? That is what he's talking about, the solid object. The boundaries are called as surfaces. Okay. Now this is a sphere, and see the red boundary. This is some block, and see this red boundary. This red boundary is surface which separates solid part from air. So no other explanation needed, and practically has no thickness. This is very important. This red has no thickness. Okay. Now I am going through these two sentences and explanation is given here. So boundaries of surface are curves or straight lines, very clear, and these lines ends in points. Okay, we'll see what does this mean. So we have, this is a solid object, solids. It's called three dimension. This has three dimension. So we lose one dimension, the two, see it goes surface. Okay, then another dimension is lost. So this is lines, and lines ends in points. Okay, so no dimension. So three dimension, two dimension, one dimension, and no dimension. So hence, going from solids to point, we lose one dimension, or called as extension. Okay. So Euclid summarize these statements as definitions. Okay. So we are stating some of these definitions from Euclid's book 1, Elements. Okay, which definition we are stating are: one is point, another line, third one is ends of a line, fourth one a straight line, fifth one a surface, sixth one the edge of the surface, and seventh one a plane surface. Okay, we will be going through the definitions of this given by Euclid in his book 1 Elements. Okay, Euclid summarized these statements as definitions. We are stating some of these definitions from Euclid's book 1 Elements. They are taken as they are in the book. First one, a point. A point is that which has no part. We will have some explanation on this. Second one, a line. Line is breadthless length. Okay. Third one is ends of a lines are points. Clear? Fourth one is a straight line is a line which lies evenly with the points on itself. This is a line. You extend it, it has some arrows on both the sides. Okay. So if you extend it, you will have points on this line. That is what is said. Fifth one, a surface is that which has a length and breadth only. Okay. On this paper sheet is a surface. Okay. Sixth one, edge of the surface are lines. See here. Okay. These are lines. And seventh one, a plane surface. Okay. This is the only surface and this is a plane surface. Plane surface is a surface which lies evenly with the straight line on itself. Okay, very clear. That is the definition of plane surface. Very easy to understand. Okay. Now we will have some explanation on this or elaborate this. Part is that which has area. Now again, what is area? Okay. So we will see this in the next slide. So we start with the definition of point. Point is that which has no part. Now part is that which has area. Again, what is area? Length, breadth, evenly are all to be defined. Then we will have many terms that will have to be defined. Okay. For this reason, mathematicians agree to leave some geometric terms undefined. Here we neglect some facts as we define point as a dot and state that it does not have dimensions or it does not occupy the area. It's not true. Okay. Though small dot occupies some area or some space. Got it? Though very small, but dot occupies some area. Okay. Similarly, if we take a definition of a line which states that line is a breadthless length, then we need to explain breadth and length. Hence, mathematicians kept some terms like a point, a line, a plane as undefined term. Okay. Now, what Euclid did? Euclid named some of these according to the dialect people follow during his time. Like a plane means a plane surface, etc. Okay. So no need to explain this further. Okay. So we move ahead. See here, Euclid assumed certain properties which were not to be proved. Okay. These assumptions are actually obvious universal truths. He divided them into two types as axioms and postulates. Okay. He used postulates for the assumptions that were specific to geometry, and axioms were used in mathematics and not only in geometry. Okay. So detailed meaning of these terms are explained in special video Write to me the comment section for a link for this video. Now let us see some of the Euclid's axioms which are as follows. The next slide. Okay. Some of the Euclid's axioms are as follows. Okay. So we are studying one by one and explanation so that we can understand it properly. First one, things which are equal to the same thing are equal to one another. Okay. Don't get confused. There is explanation here. Things which are equal to the same thing are equal to one another. That means this is a segment A, segment B, segment C. If A is equal to B, A is equal to B, and B is equal to C, B is equal to C, then A is equal to C. This A and this C, so A is equal to C. That means this is that same thing. Things which are equal to the same thing, that is A is equal to B and C is equal to B. That means both these A and C are equal to same thing, then things are equal to one another. Then things are equal to one another. That is what it means. Very simple. Okay. Or another example, area of this triangle is equal to area of rectangle, and area of rectangle is equal to area of parallelogram. Then very simple, area of triangle is equal to area of parallelogram. Okay. Read it twice. You can definitely understand it. Okay. Second axiom, if equals are added to equals, then the wholes are equal. Okay. What does this mean? Equals are added to equals. Look at this example, 5 and 5. These are two equal numbers added to another two equal numbers, 2 and 2. And answer you get is 7 here and 7 here. They are equal. The wholes they added, the sum is equal. The equals are added to equals, then the wholes are equal. Okay. Again, another example. This is a rectangle and this is another rectangle having equal areas. Okay. And this triangle and this triangle, both these triangles have equal area. If this is added to this, that is equals are added to equals, okay, then the wholes, that is the total area of this, they are equal. Okay, that is what it means. Okay. Similarly, third one, if equals are subtracted from equals, then reminders are equal. Okay, the equals are subtracted, that is here 3 subtracted equals, there is 3 is subtracted from 9 in this case, and this case you get reminders as 6 and 6, they are equal. Or consider this example, this is some figure, red part, the original equals, and this small area is subtracted from this, these are equal. Okay, then what you get is remainder is a red part which are equal. Okay, so that is what it means. Okay. Axiom number 4, things which coincide with one another are equal to one another. Okay, you will understand this with this example. This example, this is some circle, green circle labeled as G. This is yellow circle labeled as Y, and we will talk about this blue circle afterwards. Circle G coincides with circle Y. Okay, this coincides with this. Hence, circle G is equal to circle Y. Okay, that means they have same area. If you merge this circle with this, you will get this. That is green plus yellow is blue. That is just a representation there. Okay, so you got it. So things which coincide with one another, are equal to one another. Okay, and fifth one, axiom number 5, whole is greater than the part. Very simple. This is whole, this is part, that red thing is part. Naturally can see this whole, you see this is given here. This is the length of the hole, this is the length of the part, and hole is greater than the part, hole is greater than this part. Okay, so no need to explain it further. Okay, axiom number 6, things which are a double of the same thing are equal to one another. Okay, just try to follow with this example. Things which are a double of the same thing, that means this B is a double of A and D is also double of A. So I have done it twice, but it's the same thing. Okay, so if B is double of A and D is also double of A, then B is equal to D, or B and D are equal. Okay, they are double of same thing, they are double of same thing, then they are equal to one another. Okay, B is equal to 2A and D is equal to 2A, then B is equal to D. Very simple. Okay, and seventh axiom, this is double, this is halved. Okay, similar one, things which are halved of the same thing are equal to one another. That means this R is half of P, then yes also half of P. Okay, same thing here, then R and S are equal, that is R is equal to S. Okay, both are equal to one another. Okay, very simple. Now try to understand this statement properly. This is useful not only in maths but in other subjects like chemistry and physics as well. Okay, so going through the statement, magnitudes of the same kind can be compared and added or subtracted. Okay, but magnitudes of the different kinds cannot be compared. Try to understand the meaning of this with this example. For example, liters cannot be compared with meters. Okay, these are two different kinds. Or centimeter cannot be compared with grams. Okay, know this, etc. Likewise, line cannot be compared with a rectangle, or angle cannot be compared with the triangle. Okay, so try to understand this, and we will now study and discuss Euclid's 5 postulates in the next video. Okay, this is Dr. Bharat Parab helping you in your studies. If you have any difficulty in this topic of introduction to Euclid's geometry, let me know through comment section and I shall solve it. Thank you. Good luck.